I will quickly go through some slides. So the first is the why. This is a paper from 2011 when they were depicting a future that was last year. And as you can see, genomics is giving more and more workload for bioinformaticians, because the part that was the heaviest workload in the past was producing the sequences. And now you can do the library with very easy to use kits. But at the same time, you produce more and more complex data to be analyzed. And that's why it's worth giving a try to some kind of bioinformatics tools or analysis or steps, because you will have more control of a big part of your project. And then why we don't use point and click applications. First, because there aren't many. And second, because when you think about apps, they are done to do one thing, and that's it. You can't really combine the phone app with the mail app. What we really need to do is to have a workbench where we can combine things. And so rather than picking a prepackaged application that will be very limited, we prefer to have a set of bricks that we can combine. And Linux was born with this philosophy in mind, to allow application to be simple, to do one thing well, and to interconnect programs together. And the other operating systems are not quite there, because for commercial and historical reason, they were not really promoting this kind of interplay. So as you know, we are going to use the terminal. And just to clarify what's a terminal, it's a character interface. And what we see now, it's called a prompt. So there is a string of text that it's highly customizable. And so every computer has a different one. And basically, when you see the prompt, the computer is ready to receive commands from you. In my case, it's my username at my computer name. And then in blue, there is the path that is where I am in the file system. We will see that later. And dollar is a convention to say that I'm a regular user and not an administrator. Then we can type a command. We hit enter, and sometimes the terminal will print some text, and that's the output. When the program is done, it's going to show me another prompt. If we don't see the prompt, either the program is still working or with some error and the program is working forever. Here you can see that the second command is cd space public. This means change directory, move your position from where you are to a new directory called public. When I hit enter, I don't see any output. So some commands, they don't produce any output at all. They make some other changes. While the third command, ls, that means list the files, is producing an output, so I can see the files in that directory. Today, we're working with remote servers. And this is another very good reason to use a terminal, because we can have very powerful servers that a lot of users can use simultaneously. And because everything we do is carried by the network, a stream of characters will be much faster than all the bits for a full desktop picture and the mouse moving, etc. So it's much more efficient if we learn how to use that. So we have our server, multiple people can use it. And now this might be naive, but when we start to do some bioinformatics, we are sometimes tempted to do it locally in our computer because we have more control and it's more intuitive maybe sometimes. There are a lot of risks. Servers are managed by expert people and the data is redundant. So if disks fails, we don't lose any data and there is an efficient use of the resources. So even if it's a little bit more tricky at the beginning, it's worth to start working with shared servers. And that's why for this workshop, we have a shared server for everyone. So we need to learn how to connect to the server. We shared some information via email. A lot of you gave me some feedback that they managed to log in. That's great. Thank you very much. So if you use Linux or Mac OS, you have a terminal built in, and there is a simple command that is SSH space, your username in the remote server at the remote server address. When you hit enter, you will receive a prompt to enter the password, and you won't see any typing. So when you type your password, you don't see dots or asterisks, because that would give a hint on your password length. And so for security reason, you see nothing. Then you hit enter, and if the password is correct, you will be inside the server. And as you can see, in my case, I changed the prompt a little bit from the local one with my Mac name. And in that case, I went to a server called Robin. And so the prompt changed to reflect that. Putty works in a similar way. We need to enter username at address in that part. So box 1, and then we can either click open and that's it. Or if we want to save the typing, we can save a bookmark. So we type a name in the save session, box 2, we click save. And when we open Putty again, we will see in the list that server. So double clicking will save us typing T4 at Phage, etc. The first time we enter in a server, we will have a prompt, a security prompt. But because it's the first time, it's normal. So there is no risk. We just can click yes. And this also happens from the command lines, also from macOS. The most difficult part of working with the terminal is that we don't have the usual windows for finding our files. So we need to know where we are and where our files are. There is a one-on-one relationship between the icons and the terminal. So if I am in a folder and I type the command pwd, that means print the working directory, I will see where I am. I'm in a directory called cam, inside mega, inside the Latin, inside users. And you can see that the very same information in the bottom of the window where there is the status bar. If I type ls for list files, I will see the same content that there is in the directory. So yeah, there is this relationship. The only difference is that sometimes we forget about where we are or that we change the directory. So if a program isn't working, sometimes it's because we entered the wrong file name. Some concepts, current directory is where we are. So we always are somewhere. When we open a terminal, we are somewhere. By default, we are in a special directory called our home directory. And some other special directories can be elsewhere, though. Usually we have databases in a shared location. We have our reads in other places. So it's important to understand how to craft a file path. Because when a program wants the file name, actually mean the path, how to reach that file. And there are two ways of describing a dot in the file system. Exactly like in a system with coordinates, you can either have absolute coordinates or relative coordinates. So the absolute path always starts from the root. We'll see that in a minute. And relative path is relative to where I am. So if this is my file system, there is a file called report.txt, and it's, I mean, his absolute path will always be / and then home, another / litc, and then / report.txt. Absolute path, they always start with a / at the beginning, while relative paths never start with a / They start with some other symbols. In particular, to create a relative path, we need to know a couple of things. For example, that the current directory is called dot. That's a convention. So if I am in the right directory and want to enter in Andy, dot/Andy, it's a relative path, or /home/Andy is the absolute path for the same directory. Now I changed my directory. If I want from my right directory to access to the Linux PDF, I need to go back one level. So the absolute path is always the same. It would be / home / litc Linux PDF. The relative path, though, needs to have this operator to go up one level. That is dot dot. So dot is my current directory, and dot dot is the directory above my level. So dot dot /litc /linux.pdf. We're not going to make extensive use of these things for the workshop, but of course they are essential. And if you will ever want to start using the command line, this is very important that you take some time to practice with files and file paths. There is a very handy shortcut that is tilde, that is your home. Technically, it's the absolute path to your home. So even if they are in the same vignette, the first two symbols, dot and dot dot, are relative paths, and tilde is an absolute path. You don't need to type again a command. If you type the command similar, or if you want to change something, you can use the up arrow, and you will recall the last command, and you can hit up arrow again and again and scroll through your history of commands. And this is nice, but there is something that is mandatory. If you type a file path, you must use the tab completion. you will see with the practical that when we want to type the file name or the file path of something, we can use tab to complete what we are typing. Sounds like something that is just saving us some typing, but it's also making us aware that we are typing something that is correct. Because if tab doesn't work, it's because we are typing something wrong. And so we must use the tab completion every time we type a file path. Some panic management: when a program hangs or starts spitting a lot of text that is scaring us, Ctrl-C or sometimes Ctrl-D will break their execution and give us a prompt back again. All these slides are available, by the way, so no worries. Structure of some commands. So the first string we type in a terminal is the actual command. Everything else, separated by one or more spaces, are all the instructions for that command. So for example, ls space -l space /workshop. ls is the command, is the verb, is the program that will do something for us. Everything else is something that we tell to the program to change his behavior. For example, if we want to assemble some reads, we need to tell the program where are the reads and where to save the output files. So there are some parameters that will start with a minus or double minus. It's a convention, and some others you will not use that. So we call the parameters that are either on or off, like -l switches. And then there are some other parameters that will want some instructions. So for example, -s is not a switch on its own, it's rather a prefix for something else. So if I type -s in this command, I also need to type something else after. It's like to say, the value of s, of the single reads, is file name.txt. The value of -t, the number of threads, is 8. While minus careful in this case is like a switch, is either on or off. Okay, I will skip the part where there are some commands to show, but there is only one that I want to introduce. So most of the commands that we use regularly are called non-interactive. We type something like spades.py, -s, -t, -careful. We can type as many things as we want, but when we hit enter, we can leave our desk, grab a coffee, and the program will do whatever it needs to do without our help. These are called non-interactive. So they can run for 1 hour, for 10 days. They will do their things, and when they're done, they will return the prompt to us. While the interactive programs are the ones that will ask things like, do you want to continue? Yes or no. So for example, there is a very useful program to introduce what we are going to do during the practical. Sometimes we want to inspect the output files. And for this, there is an interactive viewer called less. So the syntax can be less and then the name of a file. And because it's interactive, when we type enter, we see the content of the file and we can interact with the program. So we don't have the prompt back, but rather I can scroll up and down with the arrows. I can search for patterns inside the file, and there are many shortcuts. Of course, it's important to know the one that will return us to the prompt, that is Q, to quit. Just to make a quick mention to concepts a bit more advanced, but still important. So we can redirect the output of a command inside a file. So for example, ls is the command that we saw at the beginning that lists the file of the directory, but the output is shown to me in my terminal, and when I close the terminal, I lose the output. If for some reason I want to save that output, I can use the greater than operator and then redirect the output to a new file that will be created. I will not see anything because that's exactly what redirection means. The characters, instead of flowing to me, to my terminal, they will be printed in a new file. The warning is, if you specify a file that already exists, it will be overwritten. Another very good operator that Linux gives us, and one of the reasons why we use Linux, is the pipe operator. It means take the output of the command before the pipe and use it as the input of the output after the pipe. For example, we have find that will print a list of files, and wc-l that counts the lines. So in this case, I can, with a single command, count how many files I have in a specific position. And basically, the first syntax with the pipe saves me 3 commands without the pipe. So it's one of the many convenient things that Linux offers us. In some workshops, you start with ls, pwd, and other things. I personally have a slightly different philosophy in terms of, let's try to do some genomics, if you agree. But of course, we can have some questions now.